Have you heard of Go, the language Go? Because I've been hearing a lot of people are using that language. You know, if you haven't heard
It
of
rings a bell.
It's like it sounds like it's a newer language that a lot of people are going to. I was
I've
just
also
wondering if you've ever
heard
heard
that
of it.
about Ruby.
Oh yeah.
Yeah.
Ruby's been around for a long time at this
Yeah.
point.
I think Ruby's for like email client type stuff.
Yeah, but it was.
They actually have expanded to gaming stuff and a whole lot of other things.
Yeah.
They have Ruby on Rails, don't they?
Yeah. And that was a good way to make a lot of money a couple of decades ago.
I know there's like spin-offs of Ruby called like Liquid and some other ones that
Yeah.
support for clients
RPG
use.
Maker Ace uses Ruby.
Okay.
The RPG Maker NV uses Java.
That's
So
convenient.
like, I'm not sure why they changed over
Yeah.
to Java.
Huh. All right, so let's look a bit more C++. So here we've got a class. Okay, so we're gonna do object-oriented stuff here. So our favorite circle class, class circle curly bracket, same way we define things in Java. Public becomes a keyword followed by a colon. So basically, the stuff after that is going to be considered public instead of putting public on each one, or we can say private, or we can move that around. So we're defining some variables that will be part of this class, so a radius, an x, and a y, which are all doubles. And then we define a method called setRad, and we pass it a radius, and it says this radius is equal to radius. Now it uses that arrow notation instead of a period. Okay, and we're familiar with that from C. But it basically plays the role of the period that we've seen in Java. It's saying the radius field of this object. Which in this case is a circle. Set location takes two doubles, triple x and triple y, and it sets x and y equal to those, right? And this looks like something we could be writing in Java. It would be exactly the same syntax. And then area is a method that returns to pi r, right? And that looks exactly like what we've done in Java. And distance returns the distance from the origin to the center of the circle, and there's a closing curly bracket and our annoying semicolon at the end because it's C. So all of this is really one statement: class circle, curly bracket stuff, close curly bracket, semicolon. And I think the semicolon is mandatory. All right, so how do we use this? Well, we construct a circle by just saying circle C. And we don't have to say equals new circle, etc. We just say circle C, integer x, character C, same thing. So it really looks like just another variable type, right? This constructs it, declares it, and it constructs it. And then we can call the setRadius method, so c.setRad. And we can set the location. And then we can say, let's take the area, distance, and radius, and send those to standard out with new lines in between.
So there's no malloc, but there isn't any new either.
There's no malloc and there's no new, so I think it's taking care of that automatically for you when you declare.
Does that work with like a print writer where you don't want to create a new one?
I don't know.
You're just stuck with it.
Yeah.
If I have circle C and then I want C to point to a different circle, I just have to change the circle. I can't make it.
I don't know if there's a way to make a pointer to a circle.
Copy constructor.
Yeah, but if you don't want to copy.
Is there no constructor as well?
Is there what?
There's no constructor.
I don't believe you can make constructors, but you're not required
So
to.
how different is the preprocessor then in C++ compared to C or Java?
Preprocessor.
Well, I mean, I guess like if you don't have to declare anything, you can just call it what it is.
Well, you are declaring it. You're just not constructing it explicitly. But we'll see in the next example. We can say like circle C parentheses 5 if we have a constructor that takes an argument, and that calls that constructor with that value.
It's kind of easier than you don't have to say.
It feels a little more natural, right? We don't have to make this sort of mental change of gears from this is a primitive type of object to this is an actual object instance of a class. That's a good question if you just wanted to make a arbitrary circle variable and then assign it to something else. Is there a way to do that without ending up with a circle you don't use?
Is it passed by values or anything?
That's what I'm not sure. I would kind of think maybe it's passed by reference, and there's a way to use that. Say again?
For which part? Passed by reference?
So when you pass something like a circle to a method, is it passing the address of the circle?
So you can specify that in the parameter for the method.
Okay. So that does what you'd expect, right? No big surprise. But this looks fairly familiar to us, right? A few kind of almost stylistic differences. So here's our same circle class, and we've got a constructor for circle that takes a radius and an origin and calls set radius and set location with those parameters. And then we have a constructor that takes just a radius and sets the radius and centers the circle at the origin 0, 0. And then the usual set radius, set location, and area and distance methods. And so we can construct a circle with one argument, we can construct a circle with 2 arguments. And it will do what we would hope. So that seems reasonable. So, still our circle class. And most of this looks the same as 2 examples ago, except the area method is being prototyped in here but not defined. So we say area is a method in this class. It'll return a double, takes no arguments, but we don't write any code for the body of that routine. And our class definition ends here with no code for area anywhere in sight. But down here, we define area, but we say circle : : to say this is a function called area, which is part of the class called circle. And then we write the code for it there. So we can split up the definition of pieces of this class into different modules like this.
What's the, what would you use that for?
I think it's just organization, but also possibly your own version of extension.
That's what I was thinking too.
So you could have most of your code over here, and then you can just lob in your other pieces. So that's good. I have no idea what test 14 does.
I feel like if you're slowly adding methods like that, though, wouldn't you end up with like some spaghetti code where you just keep adding functions in like a different file or something?
I think it depends how you do it.
Yeah.
I mean, I think you can get to spaghetti code through a lot of different normally well-behaved approaches. But I mean, if you look at most of the stuff we do in Java, right, most of the classes we use are several levels of extension beyond an object.
Mm-hmm.
And that could get convoluted really quickly. But it's documented. Presumably there's some forethought put into how these things happen. But even with some of the simple stuff I do, it gets really complex because I don't think it through far enough sometimes. And so it's like, what does this method do? Does it come from this class or does it come from that class, right? And they probably should have had 2 different names, but they didn't, and so it becomes confusing. think this was just showing a default constructor. So circle with no arguments, and it just does whatever initialization you need. So that one's not terribly interesting. So let's look at test 15 bad. It's not really bad. It's just different. So this is a silly class, okay? There's no reason to write a class like this, but I didn't want to get bogged down in fancy things. So this is a class called mynum, and its only purpose is to hold a number for you, okay? It's a grossly over-engineered integer. So class mynum has one variable called value, which I made public. You can construct a mynum by passing it an integer, and it'll store that integer in value. And then we have an operation we can perform called op, and we can pass a mynum to op, and it will do an operation between your current number and the number you pass to it. And the operation is multiplication. So we can multiply in the usual way. So I can say mynum x10, mynum y20, and then we can say something like y dot op x. And so that will take 20 and multiply by 10, and presumably give you 200. So we can use that exactly like this. Why used a and b instead of x and y? Well, we've got a 10, we've got a 20, and we can multiply those together. All right, so that's not surprising, right? This is still looking very Java-like. And I broke this in the earlier section, so we'll have to fix this. All right, so operator plus is a method. It takes a mynum. We take this object's value, we multiply by the argument's value. We create a new mynum, which is that product, and we return the result. I don't want an equal sign here. All right, so we'll make an A, which is 10, a B, which is 20, a Y. And then we'll say Y equals A dot operator plus B, and we'll print out the value of Y. And we still get our 200. Okay, here's the cool thing though. When we make a function called operator plus, we don't need to say y equals a dot operator plus b. We can actually just say y equals a plus b. And since a and b are objects of type mynum, it will look in the mynum class for a function called operator plus. And if it finds it, it will go ahead and run that. Right, and so a plus b is equal to 200.
Can you do something more complicated like operator and then a more complicated?
So you can do pretty much any symbol or short set of symbols that are valid in C or C++. So you can this is operator overloading, right? We're changing what a plus sign does. So you can do plus, minus, times, divide. You can do a caret for exclusive OR. You can do left and right shifts. You can do equality. You can do assignment. You can do all of it, basically. And part of the idea here is go back to when we were doing our fraction class, right? We defined these nice fractions. They had numerators and denominators and all this kind of stuff. And we wrote code so we could multiply and add and subtract and all this. But to use them, you had to do kind of goofy things like this: fraction 1 dot sum parentheses fraction 2. If you can overload the plus sign, we could just say new fraction equals f1 plus sign f2, or star f2, or slash f2. And we can overload assignments, so we can say, fraction 1 equals sign fraction 2, or equals this plus this. We can do comparison statements, and we can basically create our own data type.
Have a car array and check if they're equal.
Say again?
Check if two car arrays are equal.
Yeah, yeah.
Can you overload any symbol? Or does it have to be like a plus?
It's got to be an operator, so
Okay.
we can't overload like an E or something.
Okay, okay.
Yeah. I don't think you can. I'm wondering if there's some languages where you can do that. That's almost getting into like a macro
That's what I
type
was
of,
thinking.
yeah.
Could you overload the ternary, like the question mark?
I don't know if you can overload. I don't know if that would make sense.
Yeah, that would make sense. I'm just curious.
So unused symbols can't be used, like the @ sign or?
It's a good question. These are all really good questions.
Yeah,
Do you know the answer?
cool.
I'm pretty sure you keep that sign. Well, you could if you're doing, well not, oh sorry, not ampersand. You're doing ampersand.
Yeah, you should be able to do the logic ones.
Yeah.
How many errors did we get for that? Oh, not too many.
But you can also overload like string operators, like double.
The less than?
brackets,
Yeah, cool.
Route into a string, and you kind of see how.
Yeah. So this kind of lets you sort of more naturally extend the language, right? So that when you make your own class of objects, you can interact with them with the way that you're interacting with, say, integers and doubles and other primitive types. And that's something Java doesn't have, at least it doesn't make it easy. And some languages do, and sometimes people get really excited about this because they think it's great, and sometimes people get really worried about this because they think it's a bunch of landmines waiting to go off, right? It's like everything code doesn't kill. Coders do, I don't know. Anybody here ever hear of the language Ada? You've heard of it? Okay, Izad and I were walking a couple of days ago, and we got to the subject of Ada somehow. He's like, I bet no students here have ever heard of Ada. You look at programming languages, and it's like C has these things, but it's missing those things, right? And Python has this, but it's also missing that, right? And so people have their own favorite languages, and the maintenance of code is the predominant cost in code. Something like 90% of the cost of software is maintaining it, 10% is actually developing it. And so Department of Defense, being a huge consumer of software, got worried about this, and there were all kinds of terrifying graphs about how many trillions of dollars it would cost to maintain a piece of code in 10 years. And so they came up with the ultimate solution. They were going to invent a new language. Because that's what you do, right?
No one's ever done that. That's
Yeah.
genius.
And
So original.
and they called it Ada because Ada Lovelace was the first programmer in the mid-1800s, and so they figured they'd name the last programming language after the first programmer. It's a great idea. And Ada was just a behemoth. It was huge, and it was lumbering, and you couldn't get it to compile on most machines because the compiler was so over-bloated, or it felt that way at least. But this was one of the things that Ada made available was operator overloading, and people were really excited about this because it would make your code more natural, and it would make it less prone to sort of the peculiar bugs you get by having to change the way you add things and such.
Wasn't that one of the things that like led to object orientation?
I think so, yeah. I think it was around that era. And I took an ADA class, so I'm one of the few. But yeah, it was not the last language.
Does it do everything now? Like,
No,
no.
I don't
We'd
think
still
so.
be using it if it did everything.
Yeah.
Well, there could be other costs to it, like it's just super slow or something.
That was one of the problems. Was it was really hard to get stuff to compile. I mean, the compilers were just really complex.
It's still around.
It's still around, and it might even still be mandated by DoD. I don't know, but I was in DoD at the time, and very few people actually used it. You got exceptions saying, you know, our task is time critical, so we have to use C or BASIC or Fortran or something. You get exceptions.
That's great.
Yeah.
We'll make a new code because cost of maintaining.
Yeah. Yeah.
However, you can't code with that code.
Right.
Sense.
Yeah. All right, so let's take a 5-minute break, and then let's do a quick review of everything.
Tyler.